Good morning, everyone. Today we will learn on chapter 9 is about linked list. So linked list is basically a data structure that is used to store information. However, it has some different comparing to array, and we will talk in this lecture. Here is the brief outline for this lecture. Firstly, we will see linked list introduction. Next, we will talk about advantages of using linked list and array and what are their differences. And next we will see example how we implement linked list using C++ language. So what is linked list? It is a data structure that can store an indefinite amount of elements. The elements here referring to the data that we want to store, the information, and it can store many data as much as we want because it uses dynamic memory management. To be noticed in a linked list, each element is linked with each other with a pointer, and to access to linked list elements we need to access it sequentially. And one important to know about linked list, as we know that it consists of many elements. So what does each element represent? It should consist of data and a pointer. The data is whatever we want to store. If we have many data, okay, we just write it there to create a new data structure for representing this element. And the pointer is basically used to point from one element to another, as it is dynamically created, so we need to connect them together such that we can access it later. And there is a remark here, each element can be called a node also. Sometimes we call it a node, or sometimes we can call it element. It's just the term used for talking about this data. And the first element in the list is called head, and the last element is called tail. This is important terms that we should be considered about. And when we create a linked list, we need to create some certain data structure. The first one is element, which consists of data and the pointer. And next, we also store list structure variables, which consists of n, which represent the number of element in the list. When we add element to the list, we need to increment this variable. Next, we have a reference to the list we had in tail. So these two data structure should be created so that we can store information as a linked list in a compact way. So next we will see the pros and cons of array and list. So next we will see the array first. In an array, it is a data structure that can store many elements, but the number of elements is fixed when we create it. It is fixed size. It means that if we create an array for storing 10 information, we cannot store more than that. And after we create an array, we cannot add more elements, or we delete element from the created array. And in order to access to element in the array, we need to use index, or it's called position. For example, if you want to access to the element at slot number 9, we can access it with the index number 8 because the array basically the index starts from 0. However, you should notice that in some other language, for example in MATLAB, the index of the array is started from 1. So be noticed by yourself. Next, with an array we can access it faster because based on index given a particular position, we can access to it directly. So it allows the faster access through information. However, in linked list, as an array is a limitation on how we grow elements inside list, linked list is an advantage over the array as it we can dynamically add or delete elements from list, and it uses dynamic memory management. However, when we access to element list, it gives us slower access because we need to reference by the address as it uses pointer.
So here we will talk about types of linked list. There are two types. We have a single linked list and double linked list. Normally in a single linked list, it has a link which connects one element to another in one direction. Either we link it to its successor or predecessor. But in double linked list, it has both link to the previous and the next elements. As you can see in this picture, my list 1 is representing a single linked list, and it has head and tail, and each element connected only with one pointer. And in the second list, my list 2, it is called double list because it has one element has two directions. Either it connects to the next element or the previous one. Alright, so we will take a remark here. There is a notice on the single and double linked list. We will call it a circular linked list in case that the pointer of the tail element point to the head, which means the last element point to the first element. This is called a circular linked. And these are operations to work with linked list. We can create a list, insert new element, and when we insert, we can insert to beginning or end of the list or in any specified operation. And we can also delete or element from the list. Search element in the list, it means we looping through the list, update any element, display data, and some more functions. So next we will talk a little bit more detail on single linked. This is an example showing how data is stored on single linked list. You have the first element and you have the last element, and each element are linked to one another using the address, which is a pointer. As you can see here, for example, in the first element, the pointer stores the address of the next element, which is addressed 0x, 0f, 03, 20, and 10. If you specifically focus on the element itself, it consists of data and address to the next elements. And the element itself, it also has its address. And this address is used in the previous elements, which is used to link. So as you can see the operation with list, to be able to access to element, first we need a pointer, which is an element pointing to the first, which is the head of the list, and next we can loop through element in the list until the nil condition, because we know that the last element, it has a pointer pointing to nil. In a single linked list, we have one major drawback, is that we have an element, it cannot point to the element behind it. The previous element cannot be linked because it can only have one direction accessing. And in order to work with the linked list, we need to create two data structure. The first one is element, which is used to store data, and it also contains a pointer for linking one element to another. And we have a list in order that we can arrange the compact form of linked list. We should create a list which consists of head and tail. Where is the head of the list and where is the tail of the list. And in addition to this, we also have an n integer variable which is used to store the number of elements inside the list. Basically, when the list is first created, the value of n is 0, and when we add new element, the value of n is keep increasing one by one. This is an example how you create an empty element and you create a new element. as here notification on how we create a new element, we specify the keyword new, which is used to reserve memory address for this element. And next we can add data to this reserved location. Also, we need to update the pointer. When it has the only one element, the pointer of this element is pointing to nil. In case we want to add more element to the beginning of the list, we can simply create a new element, and next make the pointer of the element point to the head. The next option is you need to update the head to this new element. In case you remove it, you can use a free function. Make sure that before you remove it, you update the head to the next element. So here we can create a function to create an empty list. This function will return a pointer list. So first step that we need to do is we create an empty list, and next we reserve memory, and we also set the initialization of n, because when the list is first created, the value of n is 0. And next thing to do is to update the head and tail of the list into the nil, because there's no element in the list yet. Next we will take a look on how we can insert element to the beginning of the list. We can create a new function, insert beginning. Here we say insert b, and it takes two parameters. The first one is list, second one is data to be inserted. So inside this function, what we do is we create the new elements, and we make the pointer of this element pointing to head of the list, simply done by the step number 2. And next we change the head, because now E is adding to the beginning of the list. It means that E is the head now. So by writing at line number 3, we make head point to E. So last but not least, we need to update tail in case that there is no element in the list yet. Then this new element now is also become the head. But in case that there is element in the list already, we don't need to concern with the tail anymore. And finally, we need to increment the value of n, which is located in the list. So we can use ls access to n, and we plus it 1, increment by 1. So that's it for how you can insert element to beginning of the list. Display element list, you can create a function, and then you pass a list variable into it. So to do this, we need to start from head. The method is to provide a temporary variable, you point it to head, and as we know that the last element of the list it point to nil, so you can use a while loop, and the condition is not equal to nil. And each time the loop is running, you will specify the steps to move forward, which is can be done by this operation. TMP equal to TMP next. It means that whenever the loops runs again, you move the TMP variable into next, and there will be a time that TMP here will point to nil, which is the end of the list, and then the loop will stop executing. So this is how you can display element in the list. This is whatever you want, you can display, you can do operation, based on your requirement. Here this is simply explain you how you insert element to list. Create an element first, and then make the last element point to the new element, because you want to add it. The function to do this, you can consider first to check if the value of n is equal to 0. It means no element in the list yet. Insert element to n, it's the same as you insert element to beginning of the list. So you just simply call to this function when n is 0. And next, when n is not 0, there's element in the list. What you need to do is that simply create a new element, and next we change the tail. The pointer of tail now is not pointing to nil, it points to E, which is the new element. And now E should become the tail of the list. we can assign it by this way, ls tail point to e instead. Last but not least, okay, you increment the value n here. So that's it on how you can insert a new element to end of the list. There are two steps here. The first one, you check if there is any element in the list. If no element at all, inserting to end of list is the same as inserting element to beginning of the list. And if there is any element in the list, you just create a new element and then change the pointer of the current tail into this new element, and next update tail variable to be this new element. Okay, alright, so now that is done presenting all of those knowledge on linked list, and we have seen on how we store the data in linked list, how we create operation in order that we can store, like we initialize list variables, we insert a new element to beginning of list, we display all data inside a list, and we also see on how we can insert an element to end of the list. So next thing we need to do, we will come and look at implementation part, how we can